Yes, the ampacity for multi-conductor, abbreviated MC, cable is determined by National Electrical Code, abbreviated NEC, section 310.15 for 10 American wire gauge, abbreviated AWG, wire. NEC section 330.80 references table 310.15b16 for the ampacity of conductors in MC cable. Table 310.15b16 states that the ampacity for 10 AWG THHN/THWN copper conductors in NC cable is 35 amps for 75 degrees Celsius conductor temperature rating. NEC section 310.60 primarily applies to conductors rated over 600 volts, which is not typically used in industrial panel boards. Therefore, a 10 AWG THHN/THWN conductor in MC cable can be used for 35 amps when used on 75-degree connections in most industrial panel boards. To elaborate further, let's delve into the specifics of how to determine the ampacity of MC cable using the NEC. The starting point is understanding that NEC section 330.80 governs the ampacity of MC cable. This section directs you to table 310.15b16, which is the primary source for determining the allowable ampacity of conductors within MC cable. Now, let's break down table 310.15b16. This table provides ampacity values for various wire gauges and insulation types at different temperature ratings. For 10 AWG THHN/THWN copper conductors, which are commonly used in MC cable, the table specifies an ampacity of 35 amps when the conductor temperature rating is 75 degrees Celsius. This temperature rating is crucial because it reflects the maximum temperature the conductor can withstand without degrading its insulation. It's important to note that the 75 degrees Celsius rating is prevalent to many industrial panel board applications, making the 35 amps ampacity applicable in these scenarios. Now, let's address NEC section 310.60. This section deals with conductors rated over 600 volts. These high-voltage applications are typically found in specialized equipment and power distribution systems, rather than the standard industrial panel boards. As a result, section 310.60 is generally not relevant when determining the ampacity of MC cable used in typical industrial settings. To summarize, when working with 10 AWG THHN/THWN conductors and MC cable within industrial panel boards, the governing factor for ampacity is table 310.15b16, which allows for 35 amps at a 75 degrees Celsius temperature rating. However, it's essential to consider other factors that can affect ampacity. These factors include ambient temperature and the number of current-carrying conductors in a raceway or cable. When the ambient temperature exceeds 30 degrees Celsius, a correction factor must be applied to the ampacity value obtained from table 310.15b16. These correction factors are found in table 310.15b2. For example, if the ambient temperature is 40 degrees Celsius, the correction factor for a 75 degrees Celsius conductor is typically around 0.88. This means that the allowable ampacity of the 10 AWG conductor must be reduced by 12%. Similarly, when there are more than 3 current-carrying conductors in a raceway or cable, adjustment factors must be applied to the ampacity values. These adjustment factors are found in table 310.15 cone. For instance, if there are 4 to 6 current-carrying conductors, the adjustment factor is typically around 0.80. This means that the ampacity must be reduced by 20%. In practical applications, it's crucial to consider both the temperature correction and conductor adjustment factors to ensure that the conductors are not overloaded. Overloading conductors can lead to overheating, insulation damage, and potentially electrical fires. Furthermore, it's essential to consult the specific product listings and instructions for the MC cable being used. These instructions may provide additional information regarding ampacity limitations and insulation requirements. Also note that the type of termination also matters. The termination at the breaker and the termination at the equipment being powered have to be rated at least for the temperature that you are planning to use. Firstly, ensure compliance with local electrical codes and regulations. These codes may have additional requirements or restrictions regarding the use of MC cable and conductor ampacities. Secondly, consider directing factors for ambient temperature. If the ambient temperature exceeds 30 degrees Celsius, you need to apply temperature correction factors as specified in the NEC. Thirdly, account for the number of current carrying conductors. If multiple conductors are bundled together, you may need to apply adjustment factors to reduce the ampacity. Fourthly, verify the temperature rating of the terminations. Ensure that the terminations at both the source and load ends are rated for the same temperature as the conductor insulation. Fifthly, properly support and secure the MC cable. Use appropriate cable ties, straps, or other means of support to prevent strain on the conductors and terminations. Sixthly, avoid sharp bends or kinks in the MC cable. Sharp bends can damage the insulation and reduce the ampacity of the conductors. Seventhly, ensure proper grounding and bonding. Follow the NEC requirements for grounding and bonding to minimize the risk of electrical shock. Eighthly, use appropriately sized overcurrent protection. Select circuit breakers or fuses with ampacities that match the conductor ampacity to protect against overloads and short circuits. Ninthly, conduct regular inspections and maintenance. Periodically inspect the MC cable and terminations for signs of damage or deterioration. Tenthly, document all installations and modifications. Keep records of all MC cable installations, including conductor sizes, ampacities, and directing factors. Understanding the specific application and environment is crucial for determining the appropriate ampacity of MC cable conductors. Factors such as the type of load being served, the operating temperature, and the presence of other conductors can all influence the ampacity requirements. In addition to the NEC, other industry standards and guidelines may provide further guidance on MC cable installations. These standards can offer more detailed information on specific applications and environments. Always consult with a qualified electrician or electrical engineer when designing or installing electrical systems using MC cable. They can help ensure that the installation complies with all applicable codes and standards and that the conductors are properly sized for the intended load. Proper planning, installation, and maintenance are essential for ensuring the safe and reliable operation of electrical systems using MC cable. By following the NEC guidelines and best practices, you can minimize the risk of electrical hazards and ensure that the system performs as intended. When selecting MC cable, consider the specific requirements of the application, including the voltage, current, temperature, and environment. Choose a cable that is rated for the appropriate conditions to ensure reliable performance and safety. It is also important to know that there are different types of MC cable available, each with its own unique characteristics and applications. For example, some MC cables are designed for use in hazardous locations, while others are suitable for direct burial applications. Be sure to select the appropriate type of MC cable for the specific application. In conclusion, determining the ampacity of MC cable conductors requires careful consideration of the NEC guidelines, directing factors, and the specific application requirements. By following these steps, you can ensure that the conductors are properly sized and that the electrical system operates safely and reliably. Always consult with a qualified electrician or electrical engineer when designing or installing electrical systems using MC cable. They can provide expert guidance and ensure that the installation complies with all applicable codes and standards. The NEC provides a comprehensive framework for ensuring the safe and reliable operation of electrical systems. By understanding and following the NEC guidelines, you can minimize the risk of electrical hazards and ensure that the system performs as intended. Remember to always prioritize safety when working with electricity. Follow all safety precautions and use appropriate personal protective equipment. If you are not comfortable working with electricity, consult with a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. In addition to the information provided in this discussion, there are many other resources available to help you learn more about MC cable and electrical safety. Consult with industry experts, attend training courses, and read relevant publications to stay up to date on the latest information and best practices. Continuous learning is essential for ensuring the safe and reliable operation of electrical systems. The NEC is constantly evolving to reflect new technologies and best practices. Stay informed about the latest changes to the NEC to ensure that your electrical installations comply with the most current requirements. By staying informed and following the NEC guidelines, you can contribute to a safer and more reliable electrical system for everyone. Remember that electrical safety is a shared responsibility. By working together, we can create a safer environment for ourselves and others. Always be aware of the potential hazards of electricity and take the necessary precautions to protect yourself and others. With proper planning, installation, and maintenance, electrical systems can be a safe and reliable source of power. But it is important to remember that electricity is a powerful force and must be treated with respect. By following the NEC guidelines and best practices, you can minimize the risk of electrical hazards and ensure that the system performs as intended. Always consult with a qualified electrician or electrical engineer when designing or installing electrical systems. They can provide expert guidance and ensure that the installation complies with all applicable codes and standards. The information provided in this discussion is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any decisions about electrical installations. The NEC is a complex and constantly evolving document. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations comply with the most current requirements. There are many resources available to help you learn more about the NEC, including training courses, publications, and online resources. Take advantage of these resources to stay informed and ensure that you are following the latest best practices. Electrical safety is a shared responsibility. By working together, we can create a safer environment for ourselves and others. Always be aware of the potential hazards of electricity and take the necessary precautions to protect yourself and others. The key takeaway is that while 310.15 is the primary reference for Ampacity, always consider correction and adjustment factors, product listings, and local codes for a safe and compliant installation.